So as you have probably guessed from sitting here for the last 10 minutes, we are going to be talking about enabling microservices for the cloud, for big data. So my name's Luke Robinson. Again, as you've probably read already, I run pre-sales internationally for DataStax. So DataStax are the Apache Cassandra experts, and we'll get into more of that later, as I'm sure you've probably guessed. What we're going to cover in this session, if my clicker works. Oh, cool, it works on here, but not on there. Hey, there we go. Okay, off to a flying start. So today we're going to cover what microservices are. I'm going to assume, looking around the room, that a lot of people pretty much know that already, so I don't have much there. I'll talk a little bit about who DataStax is. I will talk about our view of how you would move from a monolithic architecture to a microservices architecture. I will talk about how we implement those microservices in a hybrid cloud scenario. And I will talk a little bit about our future cloud architecture possibilities as well. So first, a microservices overview. Hands up if you have heard of microservices. Pretty much everyone. Hands up if you're currently working with microservices. A fair few, excellent. So I'm not going to spend much time covering this, especially as the slide renders a little bit blurry up here. Apologies for that. I do need reading glasses. But basically the idea with microservices is that we started with a monolithic architecture where you have sort of a unified code base and a unified database serving a bunch of different business needs. The problem with that being, of course, that if one team decides they need to change something in their service or their capability, it affects everybody else. You have to retest the whole thing. There's loads of builds going on. It's affecting everyone. It doesn't scale very well, right? In the sort of interim, we had services-oriented architecture, SOA, which sort of moved along the chain a little bit, talking about, well, let's actually look at things from a service perspective. We could start exchanging payloads and over HTTP and XML, eventually JSON and stuff like that. Where we've arrived in the last few years is this idea of the microservices architecture. And that's sort of the approach that, hey, let's break out and decompose all of these business capabilities into individual services run by individual teams. We don't care what sits underneath that. It's just an API. It's just serving, JSON or whatever it is. We don't care what code it's written in. We don't really care what database sits underneath it. We don't care where it lives even. We have an application that is just consuming services. And the microservices are consuming services from each other as well. But that should only be happening at the API level, right? It should only be happening at the service level. We shouldn't care about what happens underneath. And that way we can scale things out independently. We can swap around technologies. We can use the best technology for the best job and not sort of force everyone in the whole organization to use the same set of technologies, right? Again, we can also decide where it lives. Does the microservice live on premise? Do we put it into a virtualized system with a bunch of VMs? Do we start to talk about Kubernetes and Docker and start putting them in there? Do we stick it up in a public cloud, right? Do we have some combination of the two where we have a hybrid cloud environment or even a multi-cloud environment where they're talking between those different environments, right? So a little bit about DataStax. I don't want to go too salesy here, but it's important that you know where we're coming from so you can see what our vision is afterwards. So DataStax Enterprise is our kind of core product. It is our kind of commercialized and enhanced version of Apache Cassandra. Can you raise your hands if you have heard of Apache Cassandra? Good. I like that. That's a good response. Raise your hands if you know what makes Apache Cassandra special. A few. Oh, well, thank you, the DataStax employee in the back, for that. So what makes Apache Cassandra special is that it's sort of built from the ground up to be a distributed database, right? It's built from the ground up to live in a multi-zone and a multi-region world. It is a masterless ring architecture. That means that when each node is equally important to any other node, when data comes into one node, it gets replicated around within a ring and eventually replicated around to the other data centers. It is partitioned around the nodes in a particular data center according to a schema that you set up. It is built from the ground up for low latency as well, because it is a query-driven database. You architect the data model so that it serves the queries. It's a denormalized database, right? We can sign up to 100% uptime SLAs because we have a very, very robust infrastructure. We have several customers in the States who have been running for years. One particular large national retailer has been running for 7 years without a single moment of downtime attributed to DataStax. Linear scalability is also very important to us. So basically, if you add double the nodes or double the horsepower, you get double the throughput, basically, right? So you can serve twice as many requests in the same amount of time. And that does not tail off, doesn't plateau. Finally, some of the things that we do from DataStax on top of the open source version, we integrate full text search using Solr. We integrate analytics using Spark, and that supports, of course, all your third-party AI and ML libraries. We also have a distributed graph database available, which is very, very useful for things like Customer 360, anti-money laundering, fraud, that kind of thing. And that's in use by some big enterprise customers. So you can see from the kind of logo slide, and you've probably seen 17 of these today. I apologize for that. But you can see the kind of profile of customer that we tend to go after that need that kind of power, that need multi-data center support and the 100% SLA uptimes and all the rest of that. They tend to be the larger enterprise customers. So this is proven at scale. Even when you talk about the open source Cassandra version, Apple has put up a slide at one of the dev conferences where they have over 100,000 nodes of Cassandra running behind the scenes, running iCloud. So it is very, very much proven at scale. And of course in a distributed architecture. So how would we view migrating to a microservices architecture? Well, we think that using a distributed database like DataStax Enterprise, and you might see the acronym DSE a couple times just for brevity. That represents DataStax Enterprise or our version of Cassandra. That's the first step to learning how to manage a distributed services model. So we have to take into consideration when we're putting together a cluster of multiple data centers, we have to think about replication. How many nodes are we going to replicate around in? How many other data centers are we replicating this data to? That sort of thing. We have to think about what level of consistency we want. Whether we want it eventual, immediate, whatever. How do we partition that data? That is a very, very important consideration we have. How we're going to scale it. Not dealing with any single points of failure, right? And fault tolerance. So we think of this as a journey, right? So we think about, let's start with the database and then start to figure out how we might start to think about replacing some of those legacy applications. So it's very much a journey. We don't want to come in and do a big bang. One day you're using all your legacy systems, the next day it's all microservices. That's not really realistic, right? So we think, you start with the as is, right? You've got a bunch of monolithic applications. They might be broken out by different business units or what have you, but there's still probably too much or too many business capabilities wrapped up in one code space and one database, right? That means you have problems scaling. You have single points of failure. If one application goes down, it takes the rest of them down with it. You have incredibly complicated relational databases in there with loads of link tables, and it's all just dragging itself down, and trying to get any data out of it that makes any sense is a nightmare, right? So what we can start to do is look at how do we start to take some of the load off of our monolithic legacy applications, especially the ones that are struggling to scale, right? So you can see we've got still all the same applications we had before, but what we're doing is starting to move some of the data, well, not move, replicate some of the data off using change data capture along our message bus, and start to ingest it into a couple of microservices. And these right now, in this scenario, in the first step, are read-only, right? They're there only to serve some read workloads. Now, whenever you see these two rings, those are basically representing a couple of data centers in a cluster of Cassandra, right? It could be that you've got multiple data centers, as in lots, right? So that particular read workload, you might actually say, well, I really need to scale this out, and I need to put it one on-premise, and I need to put one over here in this cloud and one over there in that cloud. And in fact, we've got a global audience for this particular service, so we can we can actually put those closer to where people live, right? So we can start to distribute them around the global cloud using a public cloud or a big private cloud, whatever, right? So it's up to you. It's using the same architecture underneath, though. And the cool thing is, from the application tier, our drivers are very, very good at trying to pick the closest and fastest set of nodes that it can to get at the data it needs, right? They sort of sit there with a list of IP addresses, and they're constantly monitoring which ones are going to work best at the time. So each one of these is therefore independently scalable, and we can decide where it lives, right? And those are serving entirely different purposes. So this particular workload, we've got enabled using our Solar search right now, right? Another workload over here might be using our graph database to provide some kind of customer 360 or fraud detection or something like that, right? And at the moment, these are sort of read-only. They're not writing back anything into any systems of record. Now, as we start to move forward, we may start to decommission some of the legacy applications. And once we're comfortable that we've got the architecture in place, we can actually start to write stuff back into a system of record. And what we want to do is once we do that, is actually start to put in that system of record as well using Cassandra, using DataStax Enterprise. And again, that is independently scalable, and that can live on-premise, or it can live in the cloud, or some combination of the two, right, as appropriate. And then finally, where we end up ideally, and everyone's laughing to themselves in here that, ideally you get rid of all the legacy applications, and you end up with a fully microservices-based architecture with lots of different workloads. And actually, we're writing into our analytics database, and we're writing into our event hub as well, right? And that's all talking and independently scalable and happy. Of course, in the real world, you're still going to have the legacy applications because they'll always be there. A panacea is this. We never quite get there. But this is the ideal world, right? And hopefully you can start to decommission some of those older ones. And again, there's a lot of decisions to make about which applications to break out, how granular to go, right? There's something called nanoservices, where if you go down too far, you're literally providing one service, and it is so small that it doesn't justify the operational cost of keeping it going, right? It doesn't, it just becomes silly. So there's a lot of art versus science stuff going in here. It's, do you decompose down by business capability? Do you start to, do domains? Do you start to dry domains and subdomains and go that way, right? Do you go by use case or verbs? I mean, there's so many different ways to skin this cat. When you go back to the DataStax world, we have to decide, well, actually, do we want to make an individual cluster that is basically one database that may be distributed amongst multiple physical locations per service? Or do we want to make a cluster that spans all the services and replicate some of the common data between them, right? There might be common data. Does that then break the microservice model, right? That in an ideal world, microservices never talk to each other's databases. They only go through the APIs, right? But can we break that, right? So there's a lot of things, there's a lot of art in the science, if you know what I mean. So, how am I doing on time? So, from a hybrid cloud point of view, we're very well set up to serve this, right? In this particular example, we have an application here that's consuming many different microservices, A, B, and C. Okay, 3 microservices, and it's one's coming from on-premise, one's coming from AWS, one's coming from Google. But actually, what we're doing is replicating the microservices between those, right? So we have coverage. Any one of these data centers goes down, there's coverage for, in most cases, there's coverage for it somewhere else within this architecture, right? And the user should never notice any difference, right? They might notice a small hiccup or an increase in latency if we lose a data center maybe. They might notice that they're having to hop further away, right? But they should still have a functioning application, right? Should still be able to serve them. Another thing to say is that our architecture will work across all these clouds. I don't have Azure on here just because I ran out of rings, but we can obviously live on Azure. We have DataStax solutions deployed on all of the major cloud providers and on-premise, and in hybrid cloud and a multi-cloud way already. Another way that you might do this is actually you could isolate the microservices to particular cloud vendors, right? So you could have a microservice that only lives on Google and is replicated amongst different Google data centers and Google, Google availability zones, purely because you want to take advantage of some tooling that's in Google that isn't in one of the other cloud vendors, right? So there may be some snazzy new web service or analytics package that you want to incorporate into that particular microservice for that particular use case, and you can use that there, right? But we can still replicate the data around between them. So this isn't just theory. We are doing this in real life. This is probably the biggest food retailer you may never have heard of unless you live in continental Europe. So it's a company called Metronome that operates in 35 countries. They had this exact problem. They needed to migrate off of legacy systems towards a microservices architecture. They were looking around for a data storage facility that could meet their needs. They really wanted to move up into the cloud while they were doing the microservices thing, so just get it all done at once, basically. So what they actually found is we ended up putting in this architecture of 165 different clusters distributed around 6 different data centers in Google Cloud, right? So spanning globally, right? They were very, very happy with this. This is operating very well at the moment. We're talking to them about future projects as well. Because we put that architecture in, that will scale up to meet their needs, right? So I just want to take a moment and talk about where we're going as a company. And I'm not just doing this as a sales pitch, because this is a little bit further down the line. This is going to be early next year before this comes out. But it is very relevant to the microservices discussion. So we have something that is going to be launching early next year called DataStax Constellation. That is our cloud platform. The main part of it will be something called DataStax Apollo, which is Cassandra as a service, right? So that'll be an on-demand thing where you basically pick how much capacity you want, what compute level you want, and it will go and spin up a Cassandra cluster for you of the appropriate size and span it across availability zones. It'll be available on all the major cloud vendors, right? We'll have Insights as well, which is a performance monitoring tool using some AI and machine learning that will be monitoring Apache Cassandra clusters, and we'll actually be making that available for the on-premise Apache clusters as well. So you'll be able to use that cloud-based tool to monitor your own Cassandra clusters. Obviously, you'll be able to use it to manage, to look at the cloud clusters as well. The thing I want to talk about today, though, which is interesting and a little bit forward-thinking, is DataStax AppStax. So AppStax is a tool that's basically trying to target people who don't necessarily need to be Cassandra experts. They don't need to learn our query language, CQL. They just want to come, they may be coming from a relational database world. They want to be able to just put a model together in an interactive tool and then go through the process of defining what their inserts and updates look like, what their, I'll show you the picture of it. So they'll go through, they'll define what their data change events, right, inserts and upserts and things like that. They will define what queries they want, and it will draw from the data model they've defined. And then they can actually deploy that out into an API. And this is very, very microservices friendly, let's say. You can start from that data model, you can build out this stuff, and we've had customers look at it and they were able to go from 0 to a deployed API in about 2 hours, right? Which is pretty cool. Obviously, you would have to expand on that, but the initial reaction to it's been very good. So that's something we're very excited about. I think that's going to make deployment of microservices based on Cassandra pretty much a push-button thing. So keep an eye on that. That will be available in the first half of next year. So I just wanted to wrap up. So first we talked about what microservices are. I hope you're all on board with that now. Then we introduced DataStax. We're the Apache Cassandra experts. Then we talked about how to transition legacy applications to a modern architecture based on microservices. And finally, we just talked about future cloud architectures. Now, I want to get in a plug because we've got a meetup happening in about an hour over there, I think the Big Data Theater. So we're actually going to have our co-founder and one of the guys who's committed a hell of a lot of code back to Apache Cassandra, Jonathan Ellis. He's a next level guy, right? He's a super genius. Come and meet us. We've got free beer. We've got free pizza. He's going to give a little talk as well, but there will be plenty of time to network with him and with the other folks from DataStax, including John and Patrick and Ellie back there. So please come and join us for that. Oh yeah, so he's giving a talk called Accelerating Development in a Cloud World with DataStax and Apache Cassandra. Pretty snazzy, huh? So, thank you very much for coming. Thanks for investing your time with us. I hope you learned something.